should I start or?
Yes.
Okay. So
you can start now, Alex.
Okay. Thank you very much
Yes.
for the invitation. I will give a short introduction about myself. My name is Alexander Kolbai. I am the head of IT and information security officer and trainer for digitalization at Mercedes-Benz GTC. It's a subsidiary of the Daimler company, 100% a subsidiary. And I have many years of international project experience and a couple of certificates about machine and deep learning from Stanford and self-driving engineer program, data science, and different certificates from deep learning AI, which was driven by Andre Ng, who is also a professor in Stanford. Also a couple of security certificates, and I'm giving a lot of trainings, speeches, and things like this at different companies like Daimler, Mercedes, the government in Bavaria, and different other companies. So I'm also a member of the Connected Autonomous Driving organization in Stuttgart. The organization was founded in October 2017. We are already around 1,000 members now. And we had already around 26 to 30 meetups now. And our meetups are focusing on autonomous driving and EV. But I will come back to the meetup a little bit later. We also have a link to different other meetups, the mother organization in Auckland, in Silicon Valley, in Berlin, Germany, Detroit, Ann Arbor, and also in China and Shenzhen. So this is a little view about what we are doing. We are giving lectures about autonomous driving, about EV, about different AI instructions. We see here, it's a lecture from Dr. Behrens. Hashim also knows him, about deep reinforcement learning, and you can already see some cars. In the other side, on the right side, you see a race we did in Bosch Abstadt. This is the center from Bosch for autonomous driving, where we had a chance to use a big racing course and train our model cars and let them race around this course. It was quite fun. So what we are doing is that we started with this small DiyRoboCar, which you can see now on the slide. A couple of people will know it as Donkey Car. And I'm also getting now to a bigger step. I'm building, or I built, let's say, a medium-sized kit car equipped with a lot of technology. I will come back later on to this project, and the target is that we will equip, after we get experience from the yellow from the Mercedes, to equip one day a real autonomous car or a delivery robot or something like this. So, but if you're talking about autonomous driving, it's good to have a look back to the history, because autonomous driving is not new. There was a professor in Germany on the TU Munich. Maybe you heard about the Hyperloop events from Elon Musk and the TU Munich. They won this Hyperloop event 3 times, and now they are start building their own Hyperloop. And one of these professors in 1980 was Dr. Dickmanns, and he was the first who developed autonomous driving together with Daimler. You can see some pictures here in the slide. And in the year 1995, they drove from Munich to Odense in Denmark. 95% of the driving was autonomous. And this was 1995, so 25 years ago around. What they used was not modern technology as we know, and as you know, what you can see here in the slides, the hardware wasn't so capability like what we have today, so strong and so fast, and we had good algorithms and things like this. But what I did is something like what you know today from YOLO, from object detection. So they used a system they called machine seeing. So they made already bounding boxes around objects, and they calculated the distance between their own car and the cars in front of them. And so this makes them possible to drive the car on the street, and also make bounding boxes around the line marks on the street, what you know today as line following and things like this. And you see, so this is not something new. And also 2004 in US, the DARPA, the American Defense Organization from the American government, started a challenge in the desert, in the Mojave Desert in US, and they gave the challenge for riding 240 kilometers completely autonomous. So the people has to start the car, and the car has to run the 240 kilometers complete autonomous. Nobody should intervene the car. In the first race, the car came only 12 kilometers. So, and then the race was over. Nobody reached the real final. This was quite funny. So here's some videos of it. And as you know, autonomous driving is very famous also from one company called Google, or now called Waymo. They started 2009, starting Sebastian Thrun. He's a German guy who was the founder or the chief of the Google X department. And they started to build autonomous cars already 2009. And very famous was this small car, which was everywhere in the media. And they collect a lot of experience and a lot of kilometers in this car, and also find out how people react on this kind of cars. And the second one, which is also well known from US, it's Tesla. So these two companies, I think they are the most important drivers of autonomous driving, actually. And here you see the latest invention. It's a Jaguar, autonomous Jaguar from Waymo, which they brought to the streets now. And they already have the license to drive completely fully autonomous in Phoenix, Arizona, and drive this car there. Hashan, you still hear me?
Yes.
Okay.
Next, we can hear you very well. Okay. Thank you.
So, if you have any question, please interrupt me. And if you don't hear me anymore, if you don't see the slides anymore, also interrupt me, please. So if you're talking about autonomous driving, we have to talk about different fundamentals. I will say about, for example, the 5 levels of autonomous driving. So we have 5 levels. The levels 0 is no automation, and level 1 and level 2 is what we see already for the normal, or for the most OEMs, which you know on the streets. They have a driver assistance system, partial automation, like line following, like a braking assistant, like parking assistant, things like this. But Audi also announced to come to level 3, but they announced 2 days ago in the media that they couldn't find a legal agreement with the European governments to bring out a new Audi A8 with the traffic jam automation, which was driving the car in level 3. So all the origin OEMs actually are only driving level 2 or level 2 plus. There's only 2 companies which they are well known already. It's Waymo and it's Tesla, which are riding or driving their cars on level 3 or level 4. Level 3 means automated driving. This means not that the car is fully driving autonomously. So the driver is still in charge of the car. He is responsible for all the reactions of the car. And if the car makes a crash, he's also responsible for it. So This means there are a lot of capabilities which are close to autonomous driving, but it's a normal human-centric driving car. And then if we are speaking about level 4 and level 5, in level 4, still the driver can interfere, but it's a completely autonomous car, but it still has a steering wheel or a brake or an emergency stop or something like this. But in level 5, it's a 100% RoboCar. So, but till we come to the step of level 5 in the full traffic, I think it will take minimum 20 years, and we will see mixed out of cars from level 1 to level 4 in the next 20 years on the streets. And this makes the things very complicated because you will have non-automated cars in the streets, you will have assistant driving cars in the streets, you will have automated driving cars in the streets, and maybe a couple of autonomous driving cars. And the organization of this will be very difficult. And that's why we have to talk also about CASE, which means connected autonomous services as security and electric. The connectivity, I will come later on also to this subject, is very important because the vehicles on the street needs to communicate with each other to know if you come to the 3 Ps, the perception, planning, and so that they know what is happening on the streets. And they also have need to have the connection to the infrastructure, because they will communicate with the cloud, with the companies, with the central servers, and also with other participants on the streets, like pedestrians, bicycle riders, motor drivers, and things like this. Autonomously, we are talking about this, what we talked now the slide before, about assistant driving, automated driving, and autonomously driving. S for shared services, safety and security, which is much more important for me than shared and services, because safety and security, especially if you're talking about autonomous driving or automated driving, is a very important case, and also the part of IT data and information security. Electric is a very important part for the future. And we are talking about battery, H2O's charging, battery production, and better efficiency programs. And when we speak about connection, what we see here in the slide is this kind of V2V or Car2X or V2X, and the different systems which can be used, like 5G or VLAN 6 to connect the cars or connect different informations on the streets, which is other, so that the cars can, for example, communicate with the lighting systems, with other cars, and they know what happened in front of them. For example, if you're driving along the street and there's an accident, let's say 2 kilometers in front of you, you will get automatically the information in your car. There will be an accident in 2 kilometers, or there will be an icy street, or there will be water on the street, or things like this. So this is very important for automated or autonomously driving. If we also talk about autonomous driving, we have to talk about design and system development. So the most important task is designing and developing a system that enables all driving tasks to be performed by the car. So the driver is fully free from driving the car. And another point is the accuracy. The vehicle must master all the situations without the driver having to intervene. So the car must be able to drive completely alone. And this is the real challenge. And we see different engineer thinking in US. They think more, okay, it's enough if the car is good enough for 70 or 80% to drive on the street, and the rest of the experience we get on the streets. And the Germans engineer, they say, okay, if the car is not fit for something like this, 101%, we don't give it out. So I think the German OEMs, they are already also able to drive autonomously, but there are a lot of different mentalities and security issues which not allows us to bring these cars directly onto the street. And also because we have another or different customer experience, what they want to have on the street, because we saw a couple of accidents from Tesla, and they were all in the media about the autonomous drive standard in the Tesla, which is still in a beta version, or they say it's not autonomous driving, it's only assistant driving. But a lot of people, they accepted it as a fully autonomously driving, and that's why it's also not allowed to use this system in Germany. But for example, in Netherlands, they have a special rule. Tesla can drive there also completely fully with their autonomous system. And there was a very interesting or funny case a couple of months ago. A driver was sleeping in his Tesla driving along the street, and the police tried to stop him, and the driver didn't wake up, and the police drive along the car and with the signal horn, and even he didn't wake up, and they tried to stop the car when they get in front of the Tesla, but the Tesla said, okay, this is only an obstacle, so I have to go over it and overcome the police car. But at the end, the driver woke up and they could stop the car. So you can see that the Teslas is already able to drive fully autonomously, which means level 4 or minimum, level 3 or minimum level 4. If we talk about automated driving, we talk about data and algorithms. If we talk about autonomous driving, we speak about a huge amount of data which is produced every day in such a car. And we speak about algorithms. They are existing already long years. We talk about AI since 1956 in the Dartmouth conference. Was Minsky, Rosenblatt, and the other American guys founded this name of artificial intelligence. But what we use today are algorithms which are basically a little bit older. We could see it, for example, in the history slide from Dr. Dickmans. They already used something like object detection, but now we use these algorithms and optimize these algorithms and make them much more better, much more faster, and use much more data which can be used to run such a car. The second part, important part, are the sensors, which are the most important part in the car. This could be LiDARs, this could be cameras, this could be ultrasonic sensors, this could be radar systems, things like this. And there are different OEMs are producing this car, this kind of sensors. For example, Valeo, they are, for example, Bosch, for example, Continental, and different companies like also Daimler. But also now Waymo started to develop their own sensors. They started to develop their own LiDARs, their own radar systems, their own cameras and things like this, because I said we have a special specification of these things, and we have the algorithms, we have the technologies, we have the people, and we can do this. So we can see Waymo is still driving this kind of autonomous driving idea very strongly and very strong. And the third one is hardware and computing power. For example, everybody knows this Tesla board, which is built in the Tesla, which is one board. All the algorithms is running over this board. The car is completely controlled over this board. It's only one board. If we look today in a normal car, we have 100 ICUs around. What Tesla did, they built an autonomous car from the scratch. So they build a board and make the car around it. And what we see from the existing OEMs today is that they use a normal car and try to make them autonomously. So they come from the back and go to the front, and this makes the things much more complicated. And Tesla started, okay, they said, okay, we want to have EV car and we want to have an autonomous car, and we build a car around these two ideas and about these two fundamentals. And everything is organized in the car especially to run these two systems, to be a V car and to be an autonomous car. The second part is the computing power. Computing power doubles every year, which is Moore's law. So every year we double our computing power. The computers get smaller and smaller and smaller, and it's very easily to build these computers into cars. That's why we talk about, for example, also edge detection as one of the possibilities. If we talk about autonomous driving, we need to talk about the 3 Ps, which is perception. So what happens around me, the 630-degree view, what is the conditions on the street, what is the weather, what happens on the street, the prediction, what will happen on next in front of me, around me, and also the planning. Hello? Hello? Hello?
Hello, we can hear you.
Yes, Alex,
okay.
We can hear you very well.
Okay. Okay.
Everything is going very well.
Okay. So in the planning, the third part of the 3 Ps is how do I come safe and comfort from A to B, so that the car can plan the route from A to B. And the last point of the fundamentals is that if we talk about autonomous, we talk about unbiased data. What you can see here, for example, on the bus, there is a face and from a person, and the algorithm recognizes it as a person, which is completely wrong. In a way, it's right; it's a person, but it's not a pedestrian. So if the algorithm in the car would detect this person, he will stop in front and let the pedestrian go, for example. And this is maybe not the right decision. So very important are the data which are produced from the different sensors and if they are really usable. So now I will come to the DiyRoboCars, and I said the speech is about democratizing autonomous driving, and our organization had an idea, how can we bring the autonomous driving to normal people and how they can learn it from the basics. And so there was a guy called Chris Anderson in US, in Auckland, United States, and he founded DiyRoboCars 5 years ago, and I will give you a short video about it. Okay, what you can see here is one of the events they did in the United States. We do the same events here in Germany, a little bit smaller. But what you can see is that these are normal people. They are not people from the automotive industry. Maybe there are some from them, but they experimenting in autonomous driving at a very low level. But they have a lot of fun. And Chris Anderson always say, if you do such events, it's important that you have a lot of fun together and things going well. And I will come now to the car and explain you what is the technology in it. It's quite simple. So it has a camera. to record the street and the lines. It has a Raspberry Pi or NVIDIA Nano. It has a PWM board. The PWM board is important to control the motors and control the steering, and motor board controller. So it's very simple. The chassis is from a simple RC car, which you can buy everywhere. The rest is mainly 3D printed, which is also very easy to get, or you can buy it. Let's say the complete car is around 300 bucks, 300 euros, and you have a small autonomous car. You need a controller for it, that's it, and a little bit software which you can download open source from the internet. So then you can start to learn driving an autonomous car. And what is this car doing? Is what you see now here in the video. It's driving along this course. It's collecting the information of the course. It can be also an outside course. It's important that it has lines outside. It has lines inside, and you can see he learned from the lines. And yeah, sometimes he didn't learn very well and do his own things what he wants. So what is the system behind this? First of all, what we are doing is driving the car with a control around the course. And you see in the image on the left side, you see the street or the race course. It has a left line, it has a right line, it has a middle line, and these three lines are recorded by the camera from the car. And then this information is taken, including the speed and including the steering information, and collected into data. This data is transferred from the car to a computer, which you can use a laptop, you can use your normal PC, or if you have a NVIDIA Jetson Nano on the car, you can directly leave it on the car. Then you can train this data. I will show you later on a little bit what is the network from it. Then you create a model. You put back this model to the car, and then hopefully it will drive the course completely autonomously. And we call this behavioral cloning or imitation learning, because he learned that the street has a left line, a right line, a middle line, and when I see something like this, I know how to go along this kind of street. So it's a very simple idea of autonomous driving. But what we are also doing now is that we put some obstacles on this track and recognize these obstacles, and the car learns to go around these obstacles. Oops. So that's what I said before. First of all, we have this control. We race this car around the course. Then we train it through a neural network. Or we have the possibility to use this kind of simulator. Let me see if I can show you the simulator here. So oops. Why I don't see this screen is not going away. Can you see the simulator?
Yes, Alex.
Okay. So if I have now connected a joystick, I can drive. Let me see if my joystick is working here in this computer or not. Yeah. So I can drive this car in the simulator around this course. and collect the same data as I will do normally on a real track, and also can train them. I'm too fast. And train them through the neural network. So we'll stop, boom, and exit. So this is what you see now here in the slide. I have to share it again. I hope I'm in the correct one. Hopefully. So there are two possibilities to train the car on a real track or to train the car on a simulator. And both data will train through a neural network. And at the end, you can put this model which are created on your car and drive the car around the course. So as I said before, what you can see here in the slide is the images which is taken from the camera. So every second, the camera takes an image, and this image has a name, and this is corresponding to a label. And in the label, I have the throttle, and I have the steering information, and the information to the connection to the image. So both of them are used to train in the network. For example, now I talked about before what the neural network can learn also in future. You can see here the speed limits, for example, or you can see the pedestrian road and things like this. You can see different IMU informations. So we are putting already more sensors on the car, and this is the what you can see here is the CNN, which is used to train the data which is collected from this kind of donkey car. It's a convolutional neural network, 2D, and the activation layer is ReLU. So it's a very simple neural network based on Keras and TensorFlow. So it's nothing very complicated. And this is already existing as an open source. You can use it out of the box and collect your data, train it through this existing network, and try to do it by your own. So if you come now to DiyRoboCar, so this was a very simple idea how to learn autonomous driving in, let's say, very simple. But we said, okay, this is very simple, and we want to be more like a real car, which has a radar, it has a LiDAR, it has cameras, it has a short, medium range radars, it has ultrasonics. So a couple of different or much more sensors, which the normal donkey car don't have. What we have in the donkey car, we have the camera. This is it. We collect the steering and the speed, but we don't have a radar sensor. What you see here is the new radar sensor from CF. It's like it's very close to be like an LiDAR, but only in one direction. The good thing, it has already 112 channels. And you can create a point cloud out of it. What we also want to have in a real car is a LiDAR, if it's a 2D LiDAR or a 3D LiDAR, and different ultrasonic sensors. So what we did is to start to use a kit car. At the beginning, I used the kit car from my daughter, which I had in my cellar. It was an old Porsche. When she was 3 years old, she got it, and it left it in the cellar, and we equipped it also with all this equipment what you see here now. And then we started also to make it a little bit more sophisticated and equipped a modern Mercedes with modern technology. It has 2 cameras, one here in the front, one here on the top. It has a GPS connection. It has around 6 ultrasonic sensors, one in the middle, one on the side, left side, one on the right side, one the same in the back. It has a 2D LiDAR. It has a 3-axis gyroscope. Has cameras we already said, and it has GPS, and it has a panel. So here is a small photo from yesterday. We drove the car around the street around our house, and I can show you some small video from it. So what is the car doing? The car is doing, it has a GPS line, and he's following the GPS line and controlling the driving according to his sensors. I can show you now. I have this car here. Let me share. Can you see the screen from the car now?
Yes.
Okay. What you see here on the left side, these are the ultrasonic measurements, which are collected. They are recorded on a SD card. We have the LiDAR information. This is the LiDAR information you get now in my room here, because the car is standing next to me on the floor, and we have the camera also here. We can use directly YOLO on the car. It's built. We can directly make object detection with YOLO on the car. But here it makes no sense in the room to show it. But let me see if I have some videos here. But we can do it later on. So this car has a lot of sensors, and I will get back to the presentation. Can you see the GPS information now?
Yes.
Okay, so this is what we collected yesterday, for example. We drove the car around our area, and first of all, we collected the GPS information from this area. So the GPS sensor took the GPS line. You can see it here in XML file, which is necessary to drive the car, because he created a map for himself, and now the street in the areas. So as more streets he's driving, as more areas he's as more GPS data or more GPS informations he's knowing, or you can give him GPS information from any GPS system. So the ultrasonic sensor is controlling the distance to other obstacles, if they are in front of them, on the side of them, and collecting all this information also on the car, and can let the car drive correctly. This is the 3-axis gyroscope output. So you have, if the car is straight, what is the temperature out of it, and things like this. And the camera output, we can see here, and I will show you later on in a simulation. But let me start it quickly in the background, because it takes a little bit while. So back to the presentation. This is the output which you can get directly from the car. You can see here the object detection made by YOLO from the car. So he detects everything. My daughter already jumped sometimes in front of the car. He also recognized street signs, important. Sorry. Then what we can also do is kind of image segmentation. Use this with the Google algorithm, or which is DeepRes3 from MIT, which is quite interesting because it's a technology which you can use international. So you give every object a special color, and the car knows which color means which object. This is very important for autonomous cars, because as you know, a camera first of all is dumb. He records a film, but he don't know what he's seeing. So you give the camera or the car the information what he's seeing over the camera, because the driver is not steering the car. And that's why image segmentation is a very interesting, very important technology, because you can use it internationally. Because if we're developing autonomous cars, we develop them internationally. So this kind of information you can use in Germany, you can use them in Egypt, you can use them in Japan, you can use them in US, because you have everywhere, you have cars, they getting a blue color, you have the streets getting this kind of pinkish color, you get the sky, you have the lighting systems and things like this, and you have an international standard to use it. We use this kind of edge detection that the car can predict where he is going and can see the street. And also this kind of line following combined with YOLO detection, object detection. This is a street where the Mercedes was going yesterday, and so he knows where he can go and which is the space he can use. What you can see here in the slide on the left side, this is from the NVIDIA DriveX platform, a very sophisticated simulation, not simulation, use case. They equipped the car with the technology, and it has object detection, distance control, line following, and object detection. They measure the distance between the cars, they measure the speed of the cars, traffic sign recognition and things like this. And the same we can do also here. This is object detection also with YOLO V3. I did here in Stuttgart on a very highly traffic street, and you can see he's recognizing all the traffic lights, the persons, the different cars and things like this. So there's very good information and for the car. And last but not least, the radar information, what we collected from the LiDAR, and which we can run in the RVs, and the Mercedes car, for example, is running on a ROS environment, actually combined with other different algorithms. So we can use the LiDAR on ROS and get all the informations from the LiDAR and all the objects around, because the good thing from the LiDAR is that it allows us to get a 360 degrees view around the car. For example, if you have a radar, you only see in one direction. If you have a ultrasonic sensor, it has only a limit window what he's seeing. The same with the camera. But the good thing of the LiDAR, it has a 360 degree. He's turning as fast as possible. This is, I think, it has 9,000 radiations per minute, actually, and getting a very good picture from the area around. So I will show you. Some of you, I think, know YonoHub. And we used also YonoHub yesterday with, oops, why it's stopped now? New share.
I think the audience are not very familiar with the YonoHub, Alex. So it would be nice if you can maybe give a quick hint about it.
The interesting thing, YonoHub is, or the company AFLabs, it's a Egypt company based in Cairo. I met them 1 year ago. I really cannot really recognize how we met each other the first time, but we met each other then the second time on the IAA in Frankfurt, and we got good friends, and I'm now next to my Daimler job kind of business consultant for YonoHub, and I'm also using YonoHub. And what we did, we used a video which was recorded from the Mercedes yesterday and stuffed it into YonoHub and produced an interesting view from the area where the car was driving. So what is YonoHub? YonoHub is a platform I call it, it's an AI development, testing, simulation, and collaboration platform. So on one side, you can develop your own algorithms in, for example, in Jupyter or in Visual Studio, and then put them in blocks, which you can see here. These are the blocks, and it's very easy to create your own environment. I will stop this here, and for example, we'll show you how easily it's possible to do it by your own. So I have, for example, a video player. Then I have a video viewer. Let's say we have 2. Then I will use YOLO detection, what we had before. Then edge. Then we need some boxes which will be drawn from YOLO around the objects. And now I'm not a developer, but I can use YOLO to develop my own pipeline. Yeah. So very simple. I'm connecting now these blocks with marking them. Then I make Control E, and it's connecting to each other. So the same I will do here with the rest of the 3 blocks, and that's it. The only thing what I need to do is now to browse to my video, which was recorded from the car. Let me see videos. But let's see. Let's do. I will take another one now, not the same what you saw before, and okay, I will call it test, save it, and then I can start it, the pipeline, and you can see now different colors down there. Red means waiting, yellow preparing the environment, then blue is preparing the blocks, and green is running. Why it's not so? Now it's starting. So it will not take very long. I think 1 or 2 minutes to execute everything. Mainly the YOLO object detection takes long, but as long I can show you or give you a short introduction about it, the dashboard of YOLO Hub. Here is the block, the pipeline builder. This is called YOLO Arc. Then we have the YOLO e-builder, where we can build our own environments. We can say, okay, we want to run the system on 1 or 2 GPUs. We want to have it on a Ubuntu system. We want to have it on this and this server. Here we can have different jobs which we can start in the backside. We have YOLO shop, YOLO store, where you can, for example, buy your own blocks which are already pre-developed. You can download them and put them in your own environment. YOLO Drive, it's a file system where you can store all your informations from your pipelines, from your videos, from your Jupyter Lab notebooks, your projects, things like this. You can see there are a couple of my projects already. GitLab is something you can put your information there. You can share it with others. You have your development platforms like Jupyter Notebook, Visual Studio Code, TI Code Composer. We have Jenkins, DevOps, and things like this. And you can add a lot of different other apps also to it. And here, what you can see here, for example, I can invite other team members to my own environment. So I'm not the only one who's working in a special project. I can say, okay, I'm not a developer, but I need a developer. He's developed me the code. I put them in a block and I created pipelines. I'm testing everything. So what I can do here is a complete machine learning lifecycle, and that's what we did before. So you can see already here now, it's went very fast, and this is the scene what you saw before on the image. It's the high traffic street. So you see, we have on the one side, we have this edge detection. We have on the other side, object detection. We can use LiDAR data. You can see here what you saw in the picture before. But you can also use it in a much more complex environment. What we have here is that we use the Waymo Open Dataset Player, or the Waymo Open Dataset, stuffed it into a player which was developed by AVE Labs. Then we created different blocks, stacked them together, and created a kind of output. And this is what we got from, for example, from the Waymo dataset. This is one small part of the dataset, and we also can use here the LiDAR data, but it will take a little bit time to set it up. But let's see if I can do it quickly in Arvis. Normally you should show now the LiDAR information. But we see a part of it, but not all. It should see a complete 3D point cloud normally. Since yesterday there's a problem, I don't know. I tried it yesterday evening, but let's see. Here it is. So we can see here's a mother with a child. There are different pedestrians on the street. This is the scenario of the car, where the car is, and this is the environment around the car. Yeah. So this is directly done from Waymo dataset. We can go back to the scenario from the and see it, what the car will see on the camera. You can see here the persons which you could see in the LiDAR also. So this is a different. This is the front camera. This is the side camera, and this is, you can see here the people walking along over the pedestrian street. What you saw already in the LiDAR information. Let's see. Yeah. Here you can see them walking over the pedestrian street. Yeah. And you see also here different kind of cars, bushes, houses, and things like this. So all these informations we can visualize in YonaHub. We can develop our own algorithms in it, stuff them into blocks, build our own pipelines, test this data, see what this data gives as a feedback, optimize this data, and I will come back to my presentation. Just told, sorry, this was the wrong button. Where's Zoom here? Yeah. How can I get back to Zoom? Share screen, yeah. So this is the part, what we called machine learning factory or ML lifecycle. We are collecting data with the car. Then we are having these data. They can be also used, collected by a simulator. Then we can label this data that the system knows what this kind of data means. Then we have the label data. We develop a model from it. We test and validate it and put it back on the car. And mostly we do this in a simulation first. And that's why we use things like UnoHub. We don't need to put it directly on the car and produce accident. We can use it directly in a simulation system like UnoHub, test it and see if it's working well. Then in the simulation, we are getting new data. We label them again, or they will be auto labeled already because we have a lot of other label data which knows the other images, and then we can auto optimize the model and bring it back in the test and validation. And at the end, we can put it on the car or put it again in a simulator and test it again. So this is a closed life cycle which we can use to first of all produce data, collect data, clean data, label data, then develop models and test and validate models and bring them back to a car or to a simulation and learn how autonomous cars will drive. So a short view, what is Waymo doing in this, and they are very famous, especially because they are one of the leaders in autonomous driving next to Tesla, and they already had 32 million driven kilometers on real streets. But the most important thing is not only what they do on real streets, they have 25,000 cars in virtual simulators, and they are producing every day 16 million kilometers per car, 60 million kilometers in their simulation. So at the end, they have already around 12 billion kilometers collected on data, which is a huge amount of data, and give them a big advantage for their own possibility to drive their cars autonomously. So the main thing from Waymo is, first of all, they not concentrating on building a car. They can use any car. But what they are doing, they are concentrating actually developing their own sensors. So cameras, lidars, radar, ultrasonic sensors. They have their own algorithms like TensorFlow and other algorithms what they are producing. They have their own data centers, very huge data centers, and they have the money to get the best people in the world to develop autonomous driving for them. And they have a really good framework already for autonomous cars, which they can implement not only on one car, they can implement it on different cars. And this is a huge advantage against all the big OEMs in the world, which they have the hardware, and they now have to develop a software for it. Waymo goes the other way around. They say, okay, we don't need a car because the OEMs, they are customers for it. But what we are doing is we are developing the framework for it, and we can trust on the framework because we, first of all, we tested on real streets, and we tested it already on simulation in a very huge amount, and we have a lot of very important data to do this. One of the famous simulators is Deep Drive. It's from Voyage. Voyage is a company also in US, they are coming from the Udacity, team. This is outsourced from them, and they developed a simulator. It's like a real video stream on the street. You can see here. It's called Deep Drive, and these kind of cars collecting all the informations in the simulation. And the good thing on simulation, what you cannot do on real streets, is that you have special situations like what you see here now. Or for example, now a ball run comes on the street, or some obstacle is on the street which is normally not on the street. You can produce all this kind of scenery which you don't have on real streets every day, and which you cannot collect with normal cars. And this is the good thing on simulation. And for example, you can build huge simulation systems and produce a lot of data and information from it. You already showed this is the pipeline which we built with the donkey car. This was another pipeline we already did. You can see here we are also saving the model on it. We make also line following with the system. So a lot of different informations. The live demo we already saw before. So what is our aim? When we go back to the DiyRoboCar number 2, which has the different sensors, the next step should be to put this framework on a kind of delivery robot, not on a real car, but first of all on a delivery robot, and see how it works, because it has the same sensors like our Mercedes. It has a LiDAR, it has these ultrasonic sensors, it has cameras, and it can be also controlled externally now. And if this works, we can start to try to put such a framework on a real car. So this is the idea from the pipeline from a very small DiyRoboCar or a little bit bigger with much more sensors, then going to a delivery robot, and at the end putting something like this on a real car. That's why yeah, we call this democratizing of autonomous driving, because this is something not everybody can do, but everybody who is interested in autonomous driving can pop in this technology, and the frameworks are available, the data are available, the tools are available, and there are a lot of teams around the world who are working in this kind of area. And it's a fascinating technology, a fascinating future technology, and yeah, very, very, very interesting. Today and tomorrow, who leads the autonomous driving patent race? This is very interesting. The International Autonomous Driving Patent Race is already driven by Bosch. He was a supplier for hardware for cars, and now they are producing a lot of very interesting autonomous software. On the other side, they have around 1,000 patents, but if you see Google or Waymo now, they have the same amount of patents like Daimler, for example, has, or like Volkswagen has. So this is not only the data from Bosch is interesting, but if you see the comparison between Google and the OEMs, so Google is quite on the same track like the bigger OEMs in the world. But if you see, if you look now on the data of the self-driving car companies going the distance, and if you see the miles per disengagement, so if the driver didn't take the steering wheel, Waymo is absolutely leading. And the second one is Cruise. And then already some other American companies are coming, and then Chinese companies or Nissan, Taiwanese or Japanese company, then already Chinese companies are coming. And you can see only Mercedes here. So the traditional OEMs are not really existing in this business actually. And this is a big challenge for them now to to fill the gap from 1.5 up to 11.154 million kilometers or miles driven by other competitors. One of the interesting things, there are a couple of companies already in US offering RoboCar shuttle services. If it's Waymo, if it's Voyage, it's Active, Bootride, it's a GM company, not a Hyundai company, and yeah. So it's very easy. You have an app. You call your robotaxi. It's coming. Actually, still a security driver inside. Then you say, okay, where I want to go on the app, and the car brings you directly there. You get out of the car, and the car goes to the next guest. So what we talked about at the beginning of the presentation about case, it's a part of services in the complete ecosystem of autonomous driving. So, but it's a very important part now. If we talk about, for example, about now coronavirus, it's very easy to bring things from A to B without a driver, without any connection between people. So where we are today, the traditional OEMs, they are somewhere between L2 and L3 assistant driving. There are a couple of very less companies, let's say L4, but still with a security driver. It's especially Waymo, it's Voyage, I think Tesla will be very soon there. It's Active, also an American company. What is coming more and more are these autonomous shuttle buses. There's a company called Navia. It's a French company, and they already implemented around 150 shuttle buses worldwide. They are driving autonomously in a defined area, and it's working the same as I showed with the Mercedes car. First of all, they collected GPS data, and so the shuttle bus knows where he has to go, and they use the rest of the sensors only to say are there any obstacles around them, and how I should act with the obstacles. The next one, air taxis. Maybe you heard about Velocopter. It's a company from Germany where it's also invested by Daimler. But I'm not so sure if this will be the next big thing, because I don't want to have all the air taxis, as much air taxis in the air as we have cars on the street now. I don't want to have any of them on my head. I think there will be a market for it, I'm sure about, but it will be like something like a helicopter on special locations like Dubai or in New York or something, where you fly from A to B in a very limited area. But where we have already autonomous driving is in the logistic area. There are a lot of industrial trucks lifting vehicles autonomously, and we have a lot of autonomous warehouses. And what we see actually is all this ride services and robotaxis, which will grow very fast in the next future. Yeah, there are two books about DiyRoboCars. It's a magazine. It's called Make, and the book, sorry, it's in German. It's from a friend of mine. He called it RoboCars with the Raspberry Pi. It's a very simple description how you can build your own small robocar with a Raspberry Pi. I think it will be available soon also in English. Yeah, even the German book is interesting because it has a lot of code and pictures and descriptions. Everybody can understand, even he cannot read German or he can understand German. And gives a good idea to build the first own small autonomous cars with different sensors like cameras and servos and ultrasonics and LIDARs and things like this. Yeah, this was it from my side, giving a short introduction how you can build your own autonomous car, or your startup for an autonomous car, and how we can learn from each other. And yeah, it's an international movement, and a lot of people working on this idea and on these platforms, and it's very, very fast growing. And the good thing is that as more people are working in this area, also private, and getting their own experience, as easier it is for the bigger OEMs to recruit the people to get their cars on the street. And I think we will see a big shift from the normal car to automated cars or to autonomous cars in the next 10 years. We already see it in the US. If you go to Silicon Valley, or if you go into China, there are already a lot of cars like this. We see it in delivery systems, which will come up. We will see it in robotaxis. So I think it's an interesting area to put your nose in, and it's a mix out of development, hardware, good ideas, team building, working together, even over country borders. So you see for example, YonoHub, it's a company in Cairo, and I'm working with them here from Germany. And we have customers also in US. So yeah, I will say thank you for your attention. And if you have questions, let me know.
Thank you, Alex, so much. It was very interesting and exciting talk, very useful. Thank you so much. And please, if you have any questions, you can send to me, you can send directly here, you can open your mic.
Well, I have a question. Sorry, I'm Haitham.
Yeah.
Great. So in one of the slides, you said that you used reinforcement learning for the model generated for the simulator data. So
exactly.
Generated from the simulator, you used reinforcement learning to train the model, but for the data collected from the real car, you used imitation learning. So I was just wondering.
No, you can use both. There are different technologies you can use to train such a. You mean this slide which I have here now? You can use different technologies to train such a car. You can use it with imitation learning or behavioral cloning, or you can use the simulator and train a car in deep reinforcement learning technology.
So there is no advantage to using reinforcement learning for the simulated data.
The point is you can learn you can learn different kind of algorithms. This is the good thing on it. So it's kind of experimental studio, and you can see what could be the better outcome of it.
Oh, okay. So,
for example, if you use a simulator, you don't need a real car, because you can put back the model on the simulator and see how it will work. And actually, there is one movement now coming also from US and from Canada. We met all 3 weeks and let race our simulated cars to against each other.
Okay.
Yeah.
Yeah. Thank you so much.
You're welcome.
Thank you, Alex. One question that I have received, and I have forwarded it on the chat. You can check it, please.
Let me see.
I can read it if you prefer.
Yeah, no, I don't think that they reached it, but they are experimenting not only in cars, they are also experimenting, for example,
drones.
yeah, what's the name called? Was also a Waymo company. This Boston Dynamics, which was bought now from a Japanese company, I think. They're investing a lot now in military robots, not only in vehicles. So DARPA is investing in a lot of different subjects. They put their money in, maybe you heard about SimCoach. For example, the American Army has a lot of soldiers in the field, but they don't have so much psychologists in the field which can talk to the soldiers if they have any traumatic experience. And they developed a system, it's called SimCoach. It's a kind of virtual reality psychologist, which you can talk as a soldier with like a real psychologist. So they are working in so many different fields. Actually, no, they didn't stop. I'm sure they are investing a lot of money still in different technology, and sometimes it's good, sometimes not so good, because I don't want to have any military robots in the field.
Thank you, Alex. Do we have any questions?
You mean if I have questions?
No. I'm talking to everyone else. So do we have any more questions?
Yeah, just one last question. What kind of simulator you would use? Yeah, I know you mentioned ROS as for development.
Yeah, ROS is not a simulator, but what we are using is Kala, what we are using is AirSim, what we are using is this DiyRoboCar simulator. What I'm experimenting actually is with Deep Drive, but it's not so easy to get it implemented already. And the support is very low level actually, but hopefully I will get it run very soon. I think there are a lot of Gazebo, for example. If we speak about ROS, we can use Gazebo as a simulator, but it's not so very good. If I would prefer a simulator, I would say I think Deep Drive is a very good simulator actually. And what also is very good as a simulator is AirSim. And we are also working in AFLabs for YonoHub to make a connection to this both of simulators.
Okay, thank you.
But Kala is already implemented in YonoHub.
Okay, thank you.
You're welcome. Any other question? So if you're interested to build such your first own autonomous car, there's a website. I will share it with you. Give me just a second. Where is it now? You're on the new sharing. Yeah. It's called DiyRoboCar.com. This is let's say, the mother of the democrated autonomous robocars. And here you can find every information to build your own car under instruction. Starting from assembling the hardware, going to installing of the software on the host, on the donkey car. So even on the Jetson Nano, you can implement it on a Raspberry Pi, you can implement it on a Jetson Nano, different platforms, Linux, Windows, or Mac. I would prefer Linux or Windows. Both is working very well, actually. But never try to implement it on a VM, because especially the simulator makes some problems in the VM. It's not really running on a VM. You need a clean Linux implementation. Mm-hmm. But here you can find everything about this DiyRoboCar. Even the connection to the Slack or to the other communication platforms from this organization. This is a completely, fully, 100% open source platform. So there's no profit behind. A lot of private people are running this platform, and everybody can add his code with it. And the good thing is under, let me see where it is. Controller, stores, Keras, where's parts? Even it's this here, parts. There's defined to implement, for example, other sensors also on the DiyRoboCar, like LiDAR, odometers, GPS, and things like this. So you can learn from it. There are a lot of videos in YouTube about, and yeah, you can find everything there. So, but this is, I think it's a good, if you go to DiyRoboCar.com, you can find a lot of useful informations to build your first own small autonomous cars driven by a camera and by behavioral cloning or using the simulator. Even the simulator you can find here. If you go to instructions, there it is.
I think it's above here.
Yeah, DiyRoboCar simulator here. Here you can find everything to implement a simulator. So if you don't want to build a car, download all the informations, implement your simulator by your own. It's not so difficult. If you have a Mac or if you have Linux, download the GIM. And here you have some installation requirements. If you have any questions, if you need any help to install the simulator, sometimes it's a bit tricky. But let me know, I can help you.
Okay, thank you.
Yeah.
Also, for the LiDAR sensor, I know normally these are expensive.
Yeah, that's why we use a 2D LiDAR, which is called a Hoover LiDAR. But you can get the cheapest one is around $99 actually. And what we are using is the A3 from RP LiDAR. It's around 600 euros. So in this, if you want to buy a 3D LiDAR, you minimum have to invest 2,500 up to 10,000 euros for a good 3D LiDAR.
Mm-hmm. The other alternative would be this thing you mentioned about a radar sensor.
Exactly. Actually, we not implemented radar sensor. We are mostly using ultrasonic sensors because it's much easier to connect to an ultrasonic sensor, for example, over Arduino. What we did here in the Mercedes, we, next to the NVIDIA platform, we implemented the NVIDIA Nano and connected all the ultrasonic sensors on the Arduino. Read the information and give the informations back to the Nano over the serial interface.
Mm-hmm. All right. This website seems very helpful. Yeah. Thank you so much.
But I also have some, if you go here to externity.net or externity EU, and on the DiyRoboCar, you can find a little bit also about the, let's see, here a little bit about the project I talked about today. And we also have a Porsche. Yeah, I told you this was the first project we had. And also the description about the hardware which is built in the car. But sorry, it's still also in German. But we will change it also to English soon.
Okay.
Okay. Any more questions? So if the coronavirus situation will be better and things will go well, I can come to Cairo and we can make one weekend to build a donkey car together. Let's see.
Yeah, this would be very interesting to have a workshop at AUC.
Yeah, exactly. We can do this.
And
So hopefully the time will get better soon. And yes, now yeah, and we can travel much more easy.